Hello everyone, I hope you all had a great break. Today we are going to start a new unit, Unit 3. In this unit we are going to focus on two types of the function, which is called polynomials and the rational function. So if you see this word is kind of confusing, don't be. We're going to definitely take time to introduce each topic. So the first part of this lesson, of this unit, is going to be introduction, and we're going to introduce some words, key terms about polynomials. If you do remember something about polynomials, which is already a good start. So before we start, let's quickly do a warm-up question. So we are going to simplify the following two expressions. So you can definitely pause the video to see what are you going to do to deal with these two expressions. Some students already figured out we are going to use, yes, you're right, combine like terms. So we're going to check sometimes some term to see if they have like terms and we just need to combine them. So let's check x squared. We do have negative 5x squared, so it's going to be negative 4x squared, then negative 3x plus 7x is going to be 4x, and 4xy plus negative 2yx, then there's going to be 2xy. Some students might argue xy and yx are different. Is actually they are same because they are multiplication, just like 3 times 2 equals 2 times 3, right? So that's why this is how do we simplify. There's nothing more like terms. We can just leave it like that. In this one, be careful, there's a minus in front of parentheses, so I prefer to just take out the parentheses first. Everything is going to change sign, right? As you can see, positive become negative, negative become positive. Now we are going to check like terms. So this time I'm going to change color. 3m squared minus negative 4 squared. M squared is going to be negative m squared. And negative 6m, yes, we have negative 5m, so it's going to be minus 11m. So lastly, it's going to be negative 9 plus 12. So it's going to be positive 3. Now we have this answer is negative m squared minus 11m plus 3. So this is going to be the ones, there's nothing more of like terms. We can just leave it like this. So some students might wonder, why do we need to do like something old things like combine like terms? Because these two expressions we're looking at is actually linked to the words we are going to introduce, which is polynomials. So polynomial, today we are going to focus on several words here. First, we are going to check some examples, and then we are going to introduce some non-example examples. Last three words, standard form, degree, and types of polynomial will be the focus of day. So let's check one by one. So before we start, actually, I want to tell you the two expressions we see for the answer here are actually very good example for polynomial. So in simple words, polynomial is more like a function, and it has variables and has whole number as exponents. So this is actually the most important part we need to focus. For example, let's give an example here. That's one of the example. And sometimes we use px, we use fx. You can use whatever the letter you like to name this function. We can also use different letters to name this variable. So this another example, we can just increase the number of exponents. You can even to the 7th power, 6th power. However, this is not a polynomial. The reason is the exponents is negative 2, which is not a whole number. So that's why it's not exponent, it's not polynomial. Another one, this is also not a polynomial, which is because again, is if you converted this to exponents, it's going to be a fraction. In the future, we're going to talk about this. So this is not polynomial. So if you see something like, Even I have whole number here, but it's not polynomial. And also another thing I want to remind you is if you see like this, it's not polynomial. Again, you have one term here, t as denominator, so it's not. Okay, but you can definitely have multiple variables. You can also have just numbers. They are all polynomial. So this is, just example and non-example to reinforce our understanding of polynomial. Next, so in the following slides, we are going to focus on the three terms here. The first one is standard form. So standard form is just the way we write it. For example, let's write down a random polynomial. So as you can see, this polynomial is, again, I just write this as a function name. It's 3t squared minus t to the third power plus t minus 2. The standard form, basically, we are going to reorder the term based on the exponents. We always put the highest one to the lowest one. And this will be our standard form. So it's really nothing fancy for this one. We just reorder based on the value of exponent. We can from the highest one, oh, sorry for my handwriting, highest to lowest. And we always put a constant term in the end. So just, several words probably hear me. Each one we call term. We already know that. And the number itself we call constant term. Again, constant meaning it's not changing. So that's why it's like this. So let's see another example. For example, let's see this. So if you see, let's see, this is g of x. This is definitely not standard form, right? You can definitely just rewrite it as a standard form, which is going to be, again, check every single exponent. The highest one is 4. So we are going to bring the whole term. Do not forget the whole term, just not just variable itself, and reorder them. So, and then it's going to be a 3, but remember it is negative, so it's negative x to the third power. Then do we have 2? Yes, we do, plus x squared, then minus 2x minus 7. So that's it. That is the standard form. I'm not saying original form is wrong. It's just sometimes we just rewrite it according to this. So next, we only have 2 terms to cover, which is degree. So degree is something like brand new for the polynomial. But also the simple way to understand this is just highest points of the polynomial. Not highest, sorry, highest exponents of the polynomial. For some students, if you are confused, the reason we mentioned degree because in the future we are going to use the degree to predict a lot of features of the polynomial. So that's one thing we need to mention for the first part. Let's see one example here. You know what? Let's see the example we had before. So for example, there's 2 example here. The first one, the highest exponent is 3, so that's why the degree for this one is 3. And this one, the degree is 4 because it's the highest point. So some student might say, hey, what if this is 1 like this? Then what is the degree for this one? Do not forget, if you see the variable, then the degree is going to be 1 because it's invisible exponent. But if we just have, let's see, this polynomial is just a constant 7. So what is the degree? It is 0. We have no variable, so invisible 0. If we put it there, it's going to be, equal as 1. So that's why for this one, if this is just constant term, then the degree is 0. So another thing I just want to share with you for the degree, but it's not really the focus because we do not see often like that. For example, this is xy squared plus x squared plus 7. If we do see the polynomial like this, then we are going to check each the exponent for each one. However, for this term, we are going to consider this is invisible 1, then this exponent is actually considered 3. This is 2, and again, this is 0, so highest one is going to be 3. So degree for this case is going to be 3. But again, we are not going to focus on too much for this type of polynomial in this unit. So you don't need to worry too much about this, but just want you to know, if you see something like this in the future, that's one thing you can understand. Okay? So very last term of the lesson is gonna be the types. So we are in this part where I'm going to just introduce some very common types we are going to discuss. Of course, if you know, based on the number of terms, we can always increase these names. So the types were based on the number of terms. So some students probably already figured out what is going to be the the name. So for example, if I just have one term here, or like 2x, or 7, or negative 2x, or just a number 3. So for this one, as you can see, they're all one term. That's why we call monomial. So some students probably already figured out what's the next type. So next time you have two terms, for example, x plus 7, 2x minus 3, or x to the third power minus x squared. All this kind of thing will have two terms. So it's going to be, yes, you're right, binomial. So next one, some students already figured out the answer. What if we have three terms? Yes, you're right. We do have a name for that. And all this kind of thing. There are three terms here, so it's going to be trinomial. So of course, if you increase the number 4 terms, 5 terms, we're going to have more names for that. You can just do some research on your own. There's a name for that. But it just commonly, we just always, we see all these terms more often than the other. So that's why I just want to give you the idea. But you can definitely do more research on that to figure out there are definitely more terms for you to understand. But some student might say, hey, what if this one, do we still call like 3 terms? Not really, because we need to simplify them to combine, and then they're going to be it's going to turn out as 2 terms, so that's still binomial. So we're actually talking about the simplified terms, and to confirm it's going to be monomial, trinomial, something like that. But that's all the terms you might hear in the future for this, for this unit. So that's why that's very basic introduction for the polynomial. In the future, this is actually a very big topic. That's why we definitely spend a long time to talk about this. So I hope this video is helpful. You can definitely replay or double check, each slide to see which one you're confused. And hopefully this video will give you more ideas about the polynomial if you are familiar with these terms, which is great. So you already have a good start of this unit, okay? Thank you so much for watching this video. See you soon, everyone. Take care.